This is section 12.9, the area of a triangle. Yes, indeed, back to, I don't even know when you learned the area of a triangle. Today we're going to find the area of a triangle if we know two sides and an angle, and we're also going to calculate the area of a triangle if we know all three sides. Now, if you remember, the formula for the area of a triangle is 1/2 the base times the height. But the height requires that it's an altitude from one vertex to the opposite side. Well, we can use the law of sines to come up with formulas for the areas of triangles even if we do not know the height or the altitude. Isn't that spiffy? I thought so too. So, the area K of triangle ABC, why they call the area letter K, I don't know. But it's given by these formulas below. Now, there are 6 formulas for the 6 different possibilities, but really only 2 structures. So you only have to really memorize 2 formulas and then rearrange the letters based on which sides and angles you know. The first scenario is 2 sides and 1 angle. And so for these examples, the angle that you know is the included angle between the 2 sides you know. So area is 1/2 BC times sine A. Notice, you know sides BC and you know the angle opposite the side whose length you don't know. So K is also 1/2 AC sine B. K is 1/2 AB sine C. So you use these if you have 2 sides and 1 angle. Well, what if you know 2 angles on one side? Well, there's another formula. This is the AAS or ASA formula. Because if you know 2 angles, you know the third angle. So K is 1/2 A squared sine B sine C sine A. Now notice the pattern here. You take 1/2, square the side you know, and then multiply that by a fraction. The numerator contains the sine of the other 2 sides, 2 angles multiplied together, divided by the sine of the angle opposite the side you know. So 1/2 A squared sine B sine C over sine A. If you know side B, it's 1/2 B squared sine A sine C over B sine B, and 1/2 C squared sine A sine B all over sine C. These letters are kind of, I don't want to say pointless, but basically you could rearrange the letters or sides of a triangle any way you want, but they're all going to have the same structure. That's true for this too. Finally, if you know the lengths of all 3 sides, there is a formula for that too. This is called Hero's formula. And so the area of the triangle is the square root of the product of S, S minus A, S minus B, S minus C, where S is 1/2 times the perimeter. This is why sometimes S is called the semi-perimeter, because it is half the perimeter. Semi meaning half. So you calculate the perimeter because you know the lengths of all 3 sides, divide it in half, and then multiply that with the semi-perimeter minus the lengths of each of the 3 sides. Multiply those 4 numbers together, take the square root, and you get the area. Let's see how this works. So example 1, we have the SAS scenario as we're given angle A 115 and sides B and C 5 and 8 respectively. So all you have to do is plug this into the formula that you were given on the previous screen. K is 1/2 BC sine of A. Plug this into your calculator yourself, see if you can get the right answer. Alright, so you plug in B is 5, C is 8, A is 115, multiply them all together, and get K is 18.1 square units. So if you have 2 sides and the included angle, you just use the formula and crank it out. It's not too difficult. Example B, this is the ASA situation. You're given angle A is 40, angle B is 70, and side C is 2. Use the formula on the previous slide or 2 slides ago to see if you can get this one. Alright, so first of all, we need to figure out the measure of angle C. That's simple enough. You just subtract the 2 known angles from 180. So angle C is 70 degrees. Hey, we have a nice isosceles triangle. How about that? Alright, so here's your formula. K equals 1/2 C squared, because C is the side we know, times sine A sine B, the sines of the 2 unknown, the 2 angles opposite the unknown sides, divided by sine C. So you plug those in. 1/2 2 squared sine 40 over sine 40 times sine 70 over sine 70. The sine 70s cancel out, and so you end up with 2 sine 40, which is 1.29 square units. Alright, so if you were given 2 angles and a side, use this formula, figure out the third angle, plug all the numbers in, and simplify. Example 3, we have an SSA. We do not have an included angle. So angle A is 40, Side A is 15, side B is 20. What do you do here? Well, remember, when we were solving for triangles, if you had an SSA, you had 0, 1, or 2 possible triangles. If you have more than one triangle, you have to find the solution to all triangles. Likewise, when you figure out the area of the triangle, you have to find the area of all possible triangles. So the first thing you want to do is partially solve the triangle to see if there is a triangle and if there is more than one possible area. So here's our ratio. There's our triangle, and as you can see, there will be a two-answer solution. So sine of 40, sine A over A is 15. So these pink lines represent the possible locations of side A, equals sine B, which is an unknown angle, over 20. So sine B is equal to 0.857. If you take the inverse sine of 0.857, you either get 59 degrees or its supplement, which is 121 degrees. So in this case, this would be the 59. This angle here would be the 121. This means we also have to get two different angles for angle C. C, if A is 40 and B is 59, then C is 81 degrees. If A is 40 and B is 121, C is 19 degrees. So this whole big one is the 81 degree angle. This little one here is the 19 degree angle. So how does that affect us solving the area of the triangle? You had to do two different answers. So there are triangles. Those are our possible angles C. This is the formula we're going to use because we know sides A and B. We just have to use the angle for side C to find the area. You'll notice I chose this one over the other formula because this one's a little simpler. So let's take a look at this green triangle first. This is the 19 degree angle. We know the two sides that include the angle. So the area of this green triangle is 1/2 15 times 20 times the sine of 19. Multiply all those together and you get your area is 48.8 square units. Well, what about the triangle where C is 81 degrees? This one. That's the whole thing now. So A and B are the same. The only difference is the angle of C. So K is 1/2 15 times 20 times sine of 81. Multiply all those together and your area is 148 square units. So if you're given an SSA, make sure you check to see if there is 0 triangles, 1 triangle, or 2 triangles in the solution. Alright, this is example 4. We have the SSS scenario. So we have A is 7, B is 8, C is 9. Find the area of triangle ABC. All you're going to have to do is use Hero's formula. So first you need to find the semi-perimeter S. 1/2 times the perimeter, which is 1/2 times 7 plus 8 plus 9. If you add those together, you multiply by 1/2, you get 12. So S is 12. Now, to find the area, plug it into the formula here. And you have S, A, B, and C. Plug them in. You get K is 12 times 12 minus 7 or 5, 12 minus 8 or 4, and 12 minus 9 or 3. So K is the square root of all those numbers multiplied together, which is 720. Square root 720, and you get that the area is 26.8 square units. So if you're given the sides of all three triangles, there's only one triangle that could comprise of those three sides. So you use this formula, find the area. It's pretty simple. Lastly, example 5. Find the area of a rhombus that has a perimeter of 100 and a 30-degree angle. See if you can do this on your own. There are probably a couple ways to do this. The easiest way is to think about how you can turn a rhombus into a triangle or triangles. And how do you do that? Well, first we know that if this is 30, this angle here is 150 because consecutive angles of a parallelogram are supplementary. So we can then cut the rhombus in half like this. You could have done it the other way too. It doesn't matter, but let's do it this way. So you cut it in half, which leaves you 75-degree angles there. And this also has to be 75 degrees because it's an isosceles triangle because all four sides of a rhombus are congruent. So how long is each side of the rhombus? Well, if the perimeter is 100, the length of each side has to be 25. So now we can take this area of this triangle here, which is 2 times 1/2 25 25 sine 30. 2 because there are two of these congruent triangles that comprise a rhombus. So the area of this triangle is 1/2 times 25 times 25 times sine 30. You double that to get the area of the entire rhombus. So that comes out to 312.5 square units. Now, there are a couple other ways you could have done it. You could have drawn an altitude from here to there and see, oh, that's a 30, 60, 90 right triangle. So this height would have had to have been 12.5, and then you could have figured out the area of a rhombus that way. And that gets you the same thing. That's basically what you did. That's it for section 12.9. It's a pretty short section. There are some formulas you will need to know before the test in a few days. If you have any questions, email me or talk to me during class.